So welcome everyone to this midterm validation seminar of the Momentum project. We are quite happy to have this webinar today, and it's quite important to us because today we are going to share the most relevant advancements and the work developed by the project so far. And we really look forward to having your feedback on the work developed. And this will be very important to further work on the project. So with no more delay, I will give the word to Sergio Fernandez Balaguer from EMT. EMT is the project coordinator, and he will give us an introduction to the project. Over to you, Sergio.
Thank you very much, Maria Jose, and welcome everyone on behalf of all the Momentum Consortia to this webinar. First of all, I would like to include some details about the introduction, the structure, and the project itself, before getting into the details of the technical topics of today's webinar. And the first ones are about the different tools we are using to get your feedback and gather your feedback and opinions. Maria Jose, the floor is yours.
Well, yes, next slide, please. Yes, just to mention, we are going to use two interactive tools today. One is the Mentimeter. We will, during each of the presentations, we will set several questions where we would like to receive your feedback. So please, to answer these questions, go to menti.com and you can introduce this code, and then you can answer the questions there directly. We recommend that you do so in a phone if you have one, or in another screen. And there we will gather your feedback. And then we will be using another tool, which is Miro. It's a whiteboard. And we ask you to please go to this link and to post any questions or any feedback or any remarks you have, to post them here. We have designed the board in a way that there are different sections for each of the presentations. So there you can leave all your comments. It's quite intuitive. Please, the next slide, please. You can just create some notes and drag them to each of the sections. And this board will still be online for the next week. So after this webinar, we will share the presentations, and you still will have more time to provide your feedback on all the topics that will be discussed today.
Then, in case you have any doubt or comment, both during or after this webinar, this is how you can reach us. So either in social media, you can take a look to the website, you can see all the messages and also interact through the Twitter account, and also by our LinkedIn group. Then if you have any more specific question or details, either on the coordination side, you can contact my colleague Irene Blázquez, who is the coordinator, but unfortunately she can't be here today with us. Or from the technical side, on the technical coordination, you can contact our partner Nommon, either Javier Burrieza, who is also attending and presenting today as a speaker, or Oliva Garcia. Here you have their contact details. And last but not least, POLIS Network, our precious colleagues and partners in this project, and also taking care of the organization of this webinar, either Niklas or Maria Jose, and also about the city pool, the group of cities following the achievements of the project and sharing knowledge with others. Those are the email addresses where you can contact them. And then let's get into the topic. So for many of you, Momentum might be familiar as a project, but probably for others, it's not. So before getting into the technical details, we would like to share with you some insights on the project, a short overview. This European-funded 3-year project basically supports cities to prepare them to handle emerging mobility solutions by developing transport models and planning tools to predict the traffic impact. So since the 1st of May 2019, the project has been running in 4 European cities: Leuven in Belgium, Thessaloniki in Greece, Regensburg in Germany, and Madrid in Spain. And each city provides detailed information related to the most urgent challenges, such as, for instance, mobility as a service, new ride-sharing services, or micromobility in this case as well. And then all the different policy analysis, computer models, and various other tools are used to provide these forecasts and policy recommendations for cities on what to expect from emerging mobility solutions in the near future. So to achieve these goals, beyond EMT Madrid, the public transport operator of the city of Madrid as coordinator, and the 3 cities we have already mentioned, we have 2 providers of technology solutions for transport planning, Nommon and Einsum, 1 transport consultancy company, TML from Leuven, plus 3 research institutions, CERTH in Greece, the Technical University of Munich in Germany, and Deusto University in Spain, plus 2 networks, POLIS and UITP. And which are the objectives? Well, disruptive technologies and emerging mobility solutions, such as mobility as a service, as already mentioned, or connected automated vehicles, new shared mobility services, or demand-responsive transport are bringing radical changes to urban mobility. And the goal of Momentum is to develop a set of new data analysis methods, transport models, and planning support tools to capture the impact of these new transport options on the urban mobility ecosystem, in order to support cities in this task of designing the right policy mix to exploit the full potential of these emerging mobility solutions. So the project focuses on 3 main aspects: the influence on traffic planning, the modal shift, and a holistic sustainable urban mobility plan. And in doing so, the project aims to answer the following questions, such as: how are the travel patterns of users in the cities with this changing situation of new mobility solutions? Or how can these new solutions be integrated into current and future traffic management and sustainable urban mobility plans? Or how these new solutions change the modal split? Or how can these new solutions help for decarbonize cities? So these are the detailed 6 main objectives which are related to this. And regarding the case studies, well, at the moment, the project has reached its halfway mark. And then data sets from our 4 project cities of Regensburg, Thessaloniki, Leuven, and Madrid have been gathered, and the first assessments have been made. So Leuven, for instance, is a relatively small university city, and many of those 100,000 inhabitants study or work at the university, and it's a spin-off. So even though Leuven has a very high rank and percentage of people cycling and walking, the modal split in Leuven is still dominated by the private car use. So the current traffic situation in the suburban area of the city is also affected by the influence of the metropolitan Brussels. And as this result, Leuven, as many other cities, is struggling with some challenges, such as congestion, and which is derived for the role of the city as a commuter hub, as well as a urban attraction. So they want to focus on developing this new transport model and including those topics. Then Regensburg aims to integrate emerging mobility solutions, such as autonomous vehicles, as well as the sharing of electric vehicles and bikes, which began recently. So the city gave the green light for testing autonomous minibuses in the beginning of 2020, last year, but Regensburg has also focused in investing in a bike sharing scheme that will start operations this year. Thessaloniki also aims to update its SAMP, which would include scenarios for 2023 and 2028. And one of the main challenges to tackle is the safety of citizens and the lack of a dense public transport network in some parts of the city. Therefore, demand-responsive transport solutions are under study, as well as new regulations to enhance micromobility and bike sharing. And finally, Madrid shares most of these concerns and challenges. especially focusing on the level of access to shared mobility means of transport, either from the central district with high access to suburbs where shared mobility services are less available, or even outer districts where there is no these shared mobility services. So the idea is to assess which is the accessibility to these shared mobility solutions and which is the potential role that this solution can play to substitute car trips and increase the access to mobility, to the mobility offer. The approach is quite holistic in terms of sharing many inputs from the different key steps of the project. We have this collaborative policy development approach. So the idea is basically using all the data gathered from the different mobility options in each city use case and try to merge by developing mobility, getting outcomes on the mobility patterns, applying also big data coming from mobile devices such as smartphones, and also integrating information coming from land use and the transport system. So if you want to know a little bit more on which have been already the outcomes, and we will also mention something afterwards, you can also take a look to the website where we have published the different deliverables which are already available, such as the challenges and opportunities for transport planning and modeling, or the data inventory and the data quality assessment. And regarding the work plan, this slide, which is quite messy because there is a lot of text, basically what it wanted to show you is that all the different work packages have already started and are interlinked and interrelated. The only two work packages which are about to start are the policy assessment, work package 6, with will use also information coming from the decision support toolset, the work package 5, which will be explained later on. And then by the end of the year, further into the year, we will start also working on guidelines and recommendations. And which are the achievements so far? Well, we have reviewed the conditions for a successful implementation of smart mobility services based on the experience of cities over the last decade. We have also identified key drivers and barriers. We have also identified which are the missing data analysis technologies and techniques, and which are the required functionalities, and therefore the required adaptation of some cycling to include this advanced transport modeling. We have also set as a starting point a set of future scenarios to be considered in the planning and design of these urban mobility policies. And we have also set a data analytics method to exploit the emerging data sources in the mobility sector. So all these will be further explained by the different speakers in the different work packages and will be more from a practical point of view, and also that's why we will get your feedback. And we would like to also end this slide by mentioning the Momentum City Pool, which is a group of interested cities that are accompanying us in the process of learning in these topics. Something which is also interesting for you to know is that Momentum is included as a good practice in the new European SAM guidelines on resilience. It was recently launched. It's a topic guide that based on the lessons learned during the COVID-19 pandemic, the guide introduces this concept of resilience in urban mobility and presents the importance of integrating this concept into the SAM process. So that's the link where you have it available. And there you will be able to take also a look on the outcomes that we have already extracted from the first months of Momentum project, how this pandemic has affected and the first results after assessing data from mobility. So the structure of the webinar will include these topics. So we will start with transport modeling and how this supports future planning will be done by our colleagues from Nommon. Then we will focus a little bit on methodologies and algorithms for mobility data analysis by the University of Deusto. Then modeling of emerging mobility solutions by the Technical University of Munich. And then the decision support tool by CERTH, which is a tool that will help cities also to feed with input and then extract some outcomes. And in the meantime, we will have all these questions and answers using the tools that Maria Jose already explained, are the Miro and Mentimeter. So that's it from my side. I hope that you will enjoy this webinar, and we're really thankful for your participation. So now the floor is yours, Javier.
Okay, are you seeing my screen?
Yep.
Yes.
Perfect. Okay, hello everybody. My name is Javier Burrieza, and today I will be introducing you to the results we obtained so far in the first technical work package of the Momentum project, in order to discuss some of the outcomes we got. The objective of this first work package was to analyze which challenges new mobility options put on the table, and also to specify the case studies that Sergio was explaining before. The specific objectives were to identify which are the most relevant policy questions in relation to these emerging mobility options, and also to characterize or assess which are the aspects that will need adaptations in our tools and techniques that we use in transport planning when these emerging mobility options will have to be taken into account. How we did this? We started from desk research on how emerging mobility options are actually playing already a role in our cities, and also what are the capabilities of the current data analysis techniques and modeling tools in the transport sector. Starting from this research, we design or create a series of alternative plausible scenarios for the future of these emerging mobility options, in order to use them in a stakeholder engagement process with several transport experts, asking them which requirements they see as important for our tools and techniques in order to guide the developments to be done in the project. Let's see some aspects about the results we got. First of all, we review several trends on urban mobility nowadays. And we identified first a set of what we call supply innovation trends that encompass not only innovative services that we all have in mind, such as mobility or urban air mobility, but also technological aspects that are relevant, such as vehicle automation and other business models or passenger services that have also a lot of interactions with these innovative mobility solutions, such as mobility as a service, of course, or the different innovative payment methods that are appearing nowadays. But we identified that it was important also to take into account the policy measures that are appearing in our cities and that may shape the future of these emerging mobility options. We are talking about urban vehicle access regulations, for instance, or the incentives to use electric vehicles. One of the elements that we wanted to address in this work package is to identify how these emerging mobility options will evolve in the next decades. For doing that, we created two kinds of scenarios. We created a group of what we called exogenous scenarios that focus on external variables to mobility, but that have a lot of influence on that, such as demographic or economics. And we used these scenarios to ask experts what are the plausible implementation level of each emerging mobility option under each exogenous scenario. We explore aspects such as the modal share that these options will achieve, or how these solutions will integrate with other models. Another group of scenarios is what we call mobility-related scenarios, where we set an explicit level of implementation of these emerging mobility options and an explicit modal share, for instance, in order to ask experts what challenges they see that the current tools and techniques will have to face if the emerging mobility options develop in that term. Focusing on the exogenous scenarios, what we did, it was to start from the 5 scenarios that the International Panel on Climate Change have for exploring how society will mitigate or adapt to climate change. We add to these scenarios other aspects that are very relevant to mobility, such as the evolution of the shared economy, or aspects such as e-commerce or telework that have even gained attraction during the pandemic, in order to draft these 4 alternative scenarios for European cities in the future. As I mentioned, we used these scenarios for approaching experts and asking them which are the expected impacts and implementation levels of the different emerging mobility options. It was particularly interesting. We did this through a Delphi poll, and it was particularly interesting to focus on which aspects gather more consensus among experts and which aspects remain unclear. With regard to the aspects that gather more consensus, it mainly was about the expansion of shared mobility services. Almost all experts foreseen an increasing modal share of this option in at least in large cities. Also, that this increase is likely to affect public transport, and obviously this is something challenging. Moreover, that mobility as a service platforms or solutions will probably gain relevance in the coming years, and that other innovative mobility options such as urban air mobility are likely to remain focused on freight delivery services or emergency services rather than for broad passenger transport. Talking about the aspects that remain more unclear or uncertain after the Delphi poll, we can focus on the expansion of vehicle automation. There were the experts didn't agree on a level of implementation of vehicle automation among different fleets. Also, the evolution of car ownership levels. You will know that there is this question about how shared mobility, for instance, will enable us to reduce car ownership levels. This, again, remain unclear after the Delphi poll. And also if the cities will take the role as operators of most of these new mobility services, as they usually do, or in some cases do with traditional public transport services. Once we reach this point, I would like to ask you, I have introduced these questions in the Mentimeter because I thought it was interesting to revisit some of these uncertain results from the Delphi poll in order to gather your opinion on that. So you can find these questions in the Mentimeter, and you can provide your answer and your opinion, and we will see if this is still unclear or not. While you answer these questions, I can go on and present the rest of the results of this exercise. The second part of this Delphi poll moved on asking experts how they see that the tools and techniques we use in transport planning will have to adapt to these emerging mobility options. one interesting result was this one that this slide that you can see in the slide, that most experts see that there is some difference in relation to the level of implementation of these emerging mobility options in around the 5%. You know, in a scenario where new urban mobility solutions achieve a modal share above 5%, it is likely that our transport models, for instance, will have to be modified or improved in order to address these transport options. Another question that it was very, very interesting, it was to ask them about what are the main challenges relating the data. This is obviously very relevant for improving transport models. As you can see, data sharing agreements were on the spotlight. This is something that have perhaps improved a bit during the last years with the development of some mobility standards for data sharing, such as this mobility data specification. But it is true that there is still a lot of room for improvement in this field. Also, in terms of what are the expected improvements in transport modeling tools, most experts pointed out that a higher degree of disaggregation is needed in our transport models, both in terms of supply and demand. And this is very relevant because most emerging mobility options introduce a new relation or interaction between supply and demand. And one quite common view among experts is that this has to be tackled through a further disaggregation in our tools. Also, new indicators or analysis that some of these new solutions introduce were also highlighted by the experts, such as this need for modeling the empty trips that vehicle automation will introduce in our cities. This was a very fast glance on the results of this work package, but you can explore by yourself in this deliverable where we report all the results from this Delphi poll and also from the broader literature review we did on the subject, and you can explore this. Thank you very much for your attention. Let's see the results. Which proportion of the shared vehicle fleets will be automated in this year? Interestingly, we see much more consensus than some months ago, where we introduced this Delphi poll. There is perhaps during I would say that in the last 2 years, there has been some of more pessimistic views about the implementation of, or about the fast pace of this implementation. So this is very interesting. We can see the other question as well. And here you can see that still with this topic, there is still a broad range of opinions, and it is actually unclear. There has been some research in the recent years and months about this, with more panel data and panel surveys about how car ownership can be reduced through these emerging mobility options. But sure, we will still, I mean, the transport sector is still in need for more evidence about this process. Indeed, let's see what the data analytics can bring to us, right, Antonio?
Thank you,
Javier. So just as Javier said, so I will show you the progress on data analysis and some data collection and data analysis. Let me share the screen. Can you see my screen now?
Yes, we can see it.
Okay, thank you. So, my name is Antonio Masegosa, and I work at the University of Deusto, as you said before, and so we were in charge of the second of the technical work packages of Momentum related to data analysis and data collection and data analysis. But today I'm going to focus on one of the main outcomes, that is the development of new methodologies and algorithms for mobility data analysis. So in general terms, the objective of this work package was to gather, harmonize, integrate, and analyze the different data sources to study travel behavior. To reach this general goal, the specific objective that we posed were first to collect, harmonize, and integrate the different data sets, and then to perform an assessment of the strengths and weaknesses of each of these data sets, and finally to develop new algorithms and artificial intelligence methods for the extraction of mobility patterns and also the identification of travel choice behavior factors. So how do we do it? So what we did was first to collect many different data sources from the 4 case studies that Sergio presented before, and from this list of data sources, we analyzed the quality in order to assess how relevant or how usable they were for the purposes of Momentum. And in the third stage, with this list of relevant data sources, what we did was to harmonize them and also integrate some of them in order to facilitate the data analysis and also the development of the new algorithms. And finally, in the last stage, we work now in the main outcomes of these work packages, that was first a set of new methodologies for mobility data analysis based on data fusion and artificial intelligence in order to take advantage of emerging data sources, but also of the heterogeneity. The second of the main outcome was a set of studies on the use of prominent big data sources to show or to prove their validity or potential to analyze and monitoring the mobility patterns. And finally, we also performed a series of studies regarding shared mobility adoption and use in order to gain more knowledge about the socio-demographic characteristics of the users of this type of services, and also about the type of use that they are doing. Before going more into detail to this main outcome, let me show you briefly the type of data sources with which been working in Momentum. So in the first 3 stages that you saw before, we collected, assessed, and harmonized more than 80 data sources from 5 different categories: transport supply, transport demand, maps and cartography, socio-demographic information, and travel times. And within each block, we can see the type of data sources we've been dealing with this work package. So let's start now with the new methodologies based on data fusion and artificial intelligence for mobility data analysis. So the first of these methodologies was developed by CERTH, and the purpose was the estimation of representative OD matrices, for example, for a specific day of the week or a peak time, so for a specific period of time. And unlike the classical approach that assumed a symmetrical distribution, our colleagues from CERTH, inspired by machine learning techniques, they developed a method that was able to deal with asymmetrical distribution and that provided higher similarity to real data than the classical approach. The second of the methodologies was a new structural similarity method whose results were very promising because it was able to capture many of the well-known mobility patterns for transport practitioners. So furthermore, its computation was highly efficient. Affected to this, we were able to compare a series of body matrices. These type of methods are important because For example, they allow us to identify differences between travel patterns because of the different seasons of the year or because of an interestingly, for example, we observed using this similarity method that along February, there was an abrupt change in mobility patterns in Madrid, and we think it was because of a greater awareness about COVID-19 even in some weeks before the lockdown in Spain. So the third of the methodologies was also developed by CERTH and consisted on an estimation method for the potential demand that can be shared by the demand responsive transport system or ride-sharing system. So unlike the other approaches in literature, what they did was to develop a framework, a single framework that integrated both demand estimation and operation optimization using a stepwise approach. And the results using data from Thessaloniki were very, very promising. And finally, the last of the methodologies developed was a set of tools to deal with shared mobility data that was done by Nommon. The first of these tools was motivated by the lack of standardization of shared mobility operational data. And what it is was to develop a new generic approach to loading, homogenizing, and modeling data for shared mobility parameters. And the second of the tools was an alternative method for user profiling that avoided the necessity of direct integration with the users, as it is the case of example of samples. So what we did was to fusion or to develop a method for that fusions shared mobility operation data and also socio-demographic data. So regarding the new studies on the use of prominent big data sources, the first of them was developed by Nommon and consisted on a comparison of body matrices extracted from a recent household survey in Madrid with those obtained using mobile network data in the same way. So this comparison was done over different features of the matrix, for example, the distribution pattern or purposes, and they found that there were a high similarity in most of the dimensions. They also found some discrepancies, mainly in terms of the purposes and so part of the early distribution, but the main conclusion was that mobile network data can help overcome travel service limitation, especially in terms of cost and use of resources. The second of the studies was also very interesting and consisted on an assessment of the implementation of the overzone Madrid Central. And to do this, our colleagues from Nommon combined several longitudinal data sources as traffic counts, mobile network data, or shared mobility operation data. For example, they found that private car demand dropped as a consequence of this overzone. They also observed that the overall mobility demand trends indicated some dissuaded demand effect, but they also find probable some modal shifts because of this overzone. Also using shared mobility data, they conclude that bike sharing did not attract private vehicle trips, but in turn, motor sharing may have attracted some of them. So in the last part of my presentation, I will show you this series of analysis mobility adoption and use in Madrid, Leuven, and Rennes. So in the case of Madrid, the analysis was also done by Nommon, using household survey data, also some mobility operation data, and most of the demographic data. They found that the mobility users tend to be young adults, mostly males. They also are mostly highly educated people. That is what. And these results are aligned with other findings in literature. Other interesting findings were that there is a large proportion of shared mobility users that own some type of public transport card. We also check that some mobility users have a higher availability of private cars for the trip when they are compared with public transport users and workers. And also they found that bike sharing services are used in combination with public transport in 22% of the trips. So now I'd like to ask you about your feedback using Mentimeter. The first of the question is related to visual mobility adoption, because as we said before, maybe there are some vulnerable groups like older people, women, low-income people, or unemployed people that may have some barriers to use or to adopt visual mobility. So we would like to ask you about, so what do you think are these barriers and the adoption are? So physical access and vehicle availability, affordability, digital gap, or the lack of knowledge about mobility services. And also we'd like to ask you about, so what is your interest on, so what of the methodologies or studies that you have presented are you interested, so are interested in. So while you are giving your feedback in Mentimeter, I will continue with my presentation. So continue with mobility adoption. In the case of Leuven, also using a survey, we analyzed the people, so the profile of the people living in household with at least one car sharing subscription versus those that they don't have a car sharing subscription. And we observed similar results in terms of age, levels of education, labor status. But interestingly, we observed that there was a majority of females in this city. Also, we observed a higher tendency to use soft modes, and the fact that the households with car sharing subscription tend to have higher incomes, higher salary, and also a lower car ownership. Using the same survey, so we also compare the people that was already doing, that want to do, that will not do car sharing, and we had very similar results to the previous study, except for two interesting aspects. The first one is a majority of females in people that is already doing car sharing, but not in the case of people that want to do car sharing. And also the fact that there were homes with very high incomes, as before, but also a higher tendency of in homes with a low income. Finally, in the case of Regensburg, also using a travel household mobility survey, so we found that the profile of people that were using car sharing was young, mostly males, highly educated. But interestingly, in this case, we found a very high percentage of students. And also, again, we found that the people, so the household tend to be or very high, to have a very high income or a very low income. So you can have more information here in these two deliverables, where we provide more in detail this study that we just summarized. So now I think we can go with the results of the questions. So regarding the methodologies that the studies are interesting to you, so we see that the majority of the people about the shared mobility adoption are critical. So it was a very interesting series of studies that covers some of the aspects, but some of the gaps that we can find nowadays in literature. So, and the second one is the shared mobility data tools and also the demand responsive transport. Okay, so we can proceed with I don't know if we have time to proceed with the other question, or maybe we can proceed to Maria. So,
okay, thank you. Thanks a lot, Antonio, for the presentation. and also Javier and Sergio for their previous presentations. And thank you for engaging also in the attendees for engaging in the Mentimeter with your responses. I would just like to remind that there's also the Miro board available. You have the link in the chat. So in case you would like to post other questions, you can do so there as well. So thank you very much. We will keep track of your comments there and we will address them at the end of the webinar. And well, I will now give the floor to Shantana Krishnan from the Technical University of Munich, and he will be presenting, he will give a presentation about modeling of emerging mobility solutions. So over to you.
Thank you, Maria. I hope my screen is visible.
Yes, it is. Yes, it is. Perfect.
Thank you. Okay, so there are over 50 sharing system operators in Europe. Well, in certain cities, they are used less. In certain cities, they are used comparatively more. A car sharing vehicle can replace 4 personal cars. Private vehicles sold per car sharing vehicle range from 2 to 5 in European cities. So, sharing systems cannot be neglected anymore, and policymakers around the world are looking for ways to evaluate them. Hello everyone, this is Shantana Krishnan, a research associate from the Chair of Transportation Systems Engineering, TU Munich, and I will be presenting the modeling tools that we developed within Work Package 4 in Momentum. I will start with a short description on the limitations of the existing strategic models and the need for extending them. Following it, I will talk about the way how we pack the new algorithms that are being developed in our work package. Subsequently, I will present the extended modeling framework that we are designing, followed by a brief on the individual models from the work package. Starting with the need for extending the strategic transport models, we all know that shared mobility services are penetrating the cities. This calls for models to evaluate them. While the modeling of shared mobility services required agent-based approaches, many cities, especially small and medium-sized ones, continue to use the strategic four-step modeling approach. Therefore, there is a need to build an intermediate approach which adopts principles from the agent-based approaches and integrates them to the existing models of the cities. This is what we do, and this will allow cities to evaluate the shared mobility services. We follow a modular approach wherein we pack the new developments as modules. For brevity, we group them into 4 categories, namely demand, fleet management, supply, and sustainability. The category demand includes the first 3 steps of traditional 4-step modeling approach, that is trip generation, distribution, and then mode choice, along with new modules for induced demand and synthetic population generation. The 4th step of the traditional modeling approach, that is traffic assignment, is included under the category supply, along with a new module for car ownership. Between supply and demand, a 3rd category called fleet management is introduced, which includes algorithms for the planning and operations of shared mobility services. For example, to locate vehicles and assign vehicles to the users. Finally, we have estimation of emission and determination of accessibility and network coverage under the category sustainability. As said earlier, one of the main objectives of this work package is to develop a modeling approach which integrates the disaggregate principles of the agent-based model with traditional 4-step approach so that cities can continue using their existing models but with extended capabilities. This new modeling approach will continue to use the trip generation and distribution steps from the 4-step approach. Within the figure, these 2 steps are part of the OD module. After this, the OD matrix is disaggregated using socio-demographic data to generate synthetic population. A discrete choice model is used to assign modes for the synthetic population. At this level, the mode choice is between conventional modes as a whole, then bike sharing, car sharing, and ride sharing. In general, several cities do not have a sufficient data to estimate a mode choice model, which includes all conventional modes and the different shared mobility services. Hence, this mode choice model between conventional systems as a whole and the different shared mobility services could be beneficial, as such a model could be used in other cities. This kind of use is possible given that we can generalize the demand characteristics of shared mobility services. For example, unique profile of users such as younger individual, possession of university degree, etc. Subsequent to the estimation of demand for different modes, the disaggregate demand of the shared services are fed into the fleet management algorithms, which assign vehicles to the users and simulate the operations of the fleet operators. Initial scheme matrix is utilized for the travel times in the first iteration. If there are any unserved demand, they are assigned to the conventional modes. Once this process is carried out, the trips completed by the shared vehicles are aggregated. This will be the OD specific demand corresponding to the shared mobility services. On the other hand, the demand of the whole conventional system is aggregated and fed into the existing mode choice model of the city. Both the OD specific demands, that is, the demand of conventional modes and the shared mobility services, are then fed into the existing traffic assignment model. Based on the traffic assignment results, it might be required to iterate the sequence from mode choice or fleet management. Once an equilibrium is reached, post-processing is carried out to calculate accessibility measures and emissions. Based on this updated modeling sequence, KPIs are calculated to estimate car ownership and induced demand, and the entire modeling sequence can be rerun with respect to these estimations. Although different equilibrium checks could be introduced within this new approach, they are avoided in view of the convergence issues and to reduce additional complexity. Of course, the complexity of this approach could be further reduced if the sharing systems have a very low penetration. By low penetration, I mean low enough to not cause substantial impact on the travel times. I'm skipping the details here. For those who are interested, please do write in the Miro board and we could send the details. Now I will quickly present the individual models that are being developed in this work package. Starting with the induced demand module, we have two different models under this. The first one aims at calculating the demand elasticity with respect to change in generalized travel cost. For this, as shown in the figure, we use a functional form based on logit model. The second model is related to the estimation of demand for station-based round-trip car sharing system. In the city of Regensburg, such a car sharing system is utilized for infrequent trips like trips to a furniture store. These trips are seldom used in the OD matrices of the traditional strategic models and are also difficult to capture in the household travel surveys. Hence, we develop a new approach to estimate these additional trips mainly based on operator data. This approach uses a multi-method framework combining a logic model to find the users and regression models to estimate the number of trips per day and number of trips per station. The next module is OD. Under this, we develop clustering algorithms to classify multiple OD matrices which are generated from cell phone records. To do the clustering, we use a similarity metric like the one shown in figure. The objective is to find a representative OD matrix for a given day and situation. Next, we have a module for synthetic population, wherein we use iterative proportional updating algorithm to generate synthetic population using household survey data, socio-demographic data, and existing OD matrix. In case of missing data for certain attributes, we use data-driven approaches to generate them. As said earlier, we are developing a mode choice model to calculate the modal split between the conventional systems as a whole and the different sharing systems. Usually, the demand for the sharing systems are low, and hence we consider them as rare events and use a penalized maximum likelihood estimation approach for building a multinomial logic model. Under fleet management, we have models for both planning and operations. By planning, I mean decisions like number of vehicles, locations of stations, etc. For these, we have models based on artificial intelligence and also use algorithms from operational research. Estimation of accessibility and network coverage will be part of these models. For modeling the operations, we have a complex controller system and simulation platform. The aim here is to mimic the task of a sharing system operator, for example, to assign vehicles to the users. Leaving out the complex interactions, on the left, we have planning related algorithms which provides the sharing system service details, for example, number of vehicles, stations, etc. On the right, we have the simulator which contains the algorithms for operations and output both fleet related and user related KPIs. Under supply, the first module is on car ownership. Here we have two kinds of models. One is at an aggregate level and the other one is a disaggregate model. The aggregate regression model is meant to estimate number of cars per traffic zone using variables such as population density and household size. On the other hand, the disaggregate logic model is meant for estimating car ownership at household level based on attributes like household income. The next development is on traffic assignment. Here, we develop models to circumvent the issues associated with centroid connectors. We use a data-driven approach to reflect the traffic conditions in local roads, which are not usually considered well in the classical assignment models. The figure in the slide shows the flow of traffic between an origin present at the top and a destination at the bottom. The middle box just illustrates how two distinct routes, yellow and green, merge together into the red route. The final development is on emission calculations. Here we use emission factors at country level and speed-dependent functions to calculate emissions. The figure shows how emission of different pollutants vary according to speed. This is a static model, and apart from this, we are also working on dynamic emission models. So to summarize, within this work package, we develop multiple new models. An intermediate modeling approach has been designed to facilitate easy integration with the existing transport models of the cities. All the developments carried out in this work package will be soon made available through a public repository in GitHub. I hope the algorithms and the models that we develop are beneficial and are of interest to you. You can write your comments and questions in the Miro board, or you can also send us a mail. Finally, we have a couple of questions for you, which you can answer through the Mentimeter. So first one, will the intermediate modeling approach, which we have designed, be useful for your city or use case? The second question is related to the individual models and has been divided into two. The current one enlists the demand-related models. Kindly select those that are of interest to you. Just a note, it is possible to select multiple answers. Okay, that's interesting. Mode choice model and induced demand. Here you will find the rest of the models. The models which belong to the category of fleet management and supply and sustainability. And it is interesting to see that many are interested in the fleet management algorithms. We will be sharing the GitHub link to the participants probably will send a mail with the link. Thank you, Nicholas, for showing the questions. Now I will hand over the floor to Joseph Maria.
Thank you, Santana Krishna. So now we are moving toward package 5, which is the decision support tool that we are developing within the project, and is the one receiving most of the developments and being tested in the cities to see its usability. So I am José María Salanova. I am a transport engineer and I work for the Center for Research and Technology, HELAS, and more concretely for the Hellenic Institute of Transport. So what is this decision support tool we are developing in the project? It's an integrated framework that will help cities to assess and evaluate different mobility systems, especially the innovative ones. If they want to apply them anywhere in the city, they will be able to do it by using the tool. So,
sorry, Josep Maria.
Yeah.
Are you sharing your screen? Because currently we're
right.
not seeing it. Now, yes. Thanks.
It's okay now, Maria Jose?
Yes. Now we can see it.
Sorry, I forgot to click the share screen. Okay, so this decision support tool is aimed for the cities to assess and evaluate innovative mobility systems. So if they want to implement micromobility, bike sharing in the city, this tool will help them to understand if they should do it and how to do it. And it's highly data-driven oriented, but also using the models developed within the project. So combining the data available with the models available, we will allow the cities to use the tool to assess what are the best, the optimum mobility schemes, and to find some numbers about them. We designed the tool in order to be used by any city. So we have foreseen 5 levels in the tool. 3 of the levels are technical, are the ones that are related to the availability of data and modeling at the cities. So level 1 is the higher level in which a small data set is needed. Level 3 is the more detailed one in which the cities need a model. So any city can use any combination of these levels. If there are data available in level 1, if there are models available, level 1, 2, and 3, because these levels are applied one after each other. We have 2 additional levels, one initial level and one final level. The initial one is to be aligned with the city strategy, to have a better understanding of what is the city needs. And the final level is dealing with monitoring the results of the actions taken after using the tool. So it's important to see if the decisions taken by using the tool are in the right direction or not, so we can monitor and fine-tune the tool. This is the diagram with the 5 levels. On the left, we have the city strategy, what are the needs, and what is the vision of the city. We're going through the different levels, and we can stop at level 1, level 2, or level 3, and then we can have this monitoring and impact assessment at any moment. So you can see different cities having different capabilities on data and modeling. We'll stop at level 1, we'll go to level 2, or we'll end up in level 3, in which we need the detailed modeling framework that it was presented by Santana Krishna a few minutes ago. So somehow this is the balancing. From the data side, the lowest requirements are in level 1, but from the level of analysis, the reach of results, the more comprehensive one is level 3. So here is where the cities will see where they can make use of the tool based on their needs, but on their capabilities. So we don't want any city not having a model or not having a lot of data not to be able to use the tool. So in level 1, we are talking about aggregated data of the city. So we will have a demo in a few minutes about this level 1. So we are talking about 5, 10, 15 numbers that are giving us the information we need for the city, area, population, value of time, and different costs. We can apply different optimization formulas using highly aggregated mathematical expressions, and we can optimize these formulas to find the optimum mobility scheme, the optimum number of bicycles, the optimum number of electric scooters. In level 2, we need more rich data set. So we need some kind of OD matrix. We need some kind of telematics from any company in the city, public transport company. It can be also taxi association. We need more granular data set. This way, we can not only define the number of micromobility scooters, the number of bikes, but we can find the concrete locations. You should have 10 bike stands, and they should be located in these areas. And in each bike stand, you should have 5, 6, 7 bicycles. So we can give, with more data, we can give a much better quality of results. Finally, level 3 is the one going to the modeling. So we need a full model of the city in any of the commercial platforms where we have. So we can go up to this level, and then to have also traffic, to see home externalities, to see the impact on congestion. So this is the level giving the most detailed results to the city decision makers and the policy makers. So we see the tool as a scientific, with a strong scientific background, but we want it to be user-friendly. So we want it to be used by city authorities, by a board of people from the city, from the different public transport operators, even from some pedestrian associations. We want it to be quite user-friendly, so not to need a very high knowledge about mathematics or transport engineering to use the tool. This approach of 5 levels is what we think it will work in order to make more appealing the tool. So even cities without data, cities without model can still use the tool and have some insights on what kind of mobility solutions they should apply. Policymakers can use the tool to assess these innovative mobility schemes, and then they can apply the right policy measures based on these results. Of course, the monitoring module is important because it's allowing us to fine-tune and to see if our decisions were correct or not, or we should correct something on the tool, on the data we entered. We are talking about, I talk about cities, but it can be applied to different areas of the city. I want to see only a district in the city, so I can concentrate in this area, so the tool can deal with it. So thank you for your attention. Now I will move to the demo about the tool. This is the tool. It's this moment is on the internet, so you can access to it. It's still a mock-up and a very initial version. It will be ready before the summer, the first final version, and after the summer, the one that we will deliver. And what you see here is only level 1. But we think it's interesting to do this brief demo so you can have a better visualization of what are we doing. So here you can select the country. In our case, we have the countries of the cities presented by Sergio that are part of the project. Within the country, you can choose the city, only Thessaloniki for Greece. But of course, when we will deliver the tool, we will have all countries, all cities. So there will be the capability of being used by any city. Then the population is coming automatically when we select the city. We are taking it from Wikipedia, from statistical databases. But again, you can change it, you can update it because the one you have is more updated than the one we have on our database. Also, the area is something that you can select. We are, in general, you will see that we are trying to facilitate the use of the tool. So we are providing for Thessaloniki different municipalities, areas, or in this case, you can see this is the municipality of Thessaloniki, this is the metropolitan area of Thessaloniki. So you can select any area you want, you can save it, and you can say, I want to apply the tool to this area. You can do it also manually. You can say, I want to go to Greece, and I want to select in Thessaloniki this area that is not a municipality, is not a a region, but I want to analyze this data. So you can use any area, any polygon in Europe and anywhere in the world, and work with this. Again, we are giving to you the area of this polygon. You can again update it if the calculation is wrong. Here is when you can select what kind of mobility solution you are going to test. For today, we have ride sharing, which is the one that is already implemented and it's offerable. We can work with it. But after the end of the project, we will have bike sharing, ride sharing, micro mobility, car sharing. We will have the different innovative mobility schemes. So going to ride sharing, very brief. Ride sharing is, as we see it, is the use of a taxi by more than one person. So we need some data about the cost of operating such a system. For example, 3 hours per kilometer of operating a taxi, 5 hours per hour of having a taxi in the streets, 25 hours per hour to have a driver working. All these values now are really tentative, but you can change them and put any value you want, which is realistic of your country, your area, your city. Demand, the trips per hour, and it's 10, but it's trips per hour and per unit of area. So it's not only 10, it's 10 multiplied by the area. Average speed, this is important. Some cities have a good average speed, some cities have more congestion, so the average speed of taxis can be up to 30, 40, in some cities it can be up to 10, 15, depending on the time of the day. And value of time. This is important because people will wait for these taxis to pick them up. We can select the ranges in which we want to work. The two important decisions we see here are basically how many taxis I will allow to do this service. Taxi market is quite regulated in cities, and these numbers are quite fixed. This is the number of taxis in some cities, not in most cities, and these are the licenses. So this is a way to find how many licenses should I give to the ones willing to do this service, between 1 and 100, but this will be also something that you can modify. And then the number of passengers, between 2 to 4. So I may want my taxis to be crowded up to 4 people, or no, today we have coronavirus, so I will allow them to be up to 3. So I can modify these values, then I can calculate, and when I calculate it, it's optimizing. Sorry, I need to reshape. It's optimizing, and it's finding the optimal number of taxis. Here you have on the left the system cost. How much does it cost to operate a system with 1 taxi, 10 taxis? So it seems that the optimal value is 73 for 2 passengers, 68 for 3 passengers, and 67 for 4 passengers. So I know that in my city, I can select to give 73 licenses, but allow them to be only 2 persons per taxi. I can give less licenses and allow them a higher capacity per taxi. So this is a way that I can do some scenarios, and I can end up to some support to the policy-making organization about the number of licenses, the way they operate. Of course, here we have just the total cost, but we will have more indicators about distance, waiting time of customers, emissions. This is the demo. It's only level 1. It's still, you saw the few data you need, so you can do it for your city quite fastly. You can calculate any scenario you want, and you have some answers. So this is how we see the tool, and this is the end of my presentation. So now we will move to the questions, in which we want an initial feedback from you about the tool, about what you just see. So it's level 1, level 2, and level 3 will be much more complex. But about level 1, please let us know if you think the results are presented on a good way, and then you have an open text answer to tell us how you would like these results to be presented. Okay, it's good that you don't want them to be presented in a different way. Still, please, here you can give us any idea If not now, you can do it in the Miro at any moment. I think it will be open for a few days after this meeting. So any feedback about you being a city manager, being a public transport operator, and how to improve the results. We want this tool to be easy to visualize, to be easy to communicate. So the results and the way we show them is very important for us. Okay, maybe we can move then to the next question. Again, a couple of questions. The first one is related to, do you think that this tool is helpful for decision makers? Do they need this kind of tool to help them to their work, or it's something that they would not rely on? Okay, I'm quite glad that everyone sees that this tool is helpful. Indeed, in Work Package 6, as said by Sergio, we are testing this tool. We are having some stakeholder groups. So we will see the reaction of these stakeholder groups to the use of the tool. I hope them to be as positive as the audience of this workshop. And finally, any suggestion, any addition to what we presented that will allow you to make a better use of the tool, it will be very welcome. Again, Miro will remain open, so you can share this tool with your colleagues and have offline feedback will be very welcome.
Okay, thank you very much, Josep Maria. And thank you very much as well, Santana Crista. I see some information coming up now.
Yes, indeed, it can be interesting to keep the results and compare different cities to see what are the characteristics that are against any kind of solution. Yeah, exactly. Emissions, carbon footprint, this is one of the indicators we want to have. Travel distance as well, total kilometers, waiting time. Okay, Maria Jose, I think it's okay from our side. Thank you, everyone.
Okay, thank you very much. I think there's no more input coming right now. But yes, it was really useful to hear the presentation from Santana Krishnan, sorry, on the modeling options, and really very nice to see also how this demo and to imagine how this tool is going to be for cities and for other stakeholders that may use it. So thank you all of you. Let's go now to the Miro. I see there's not much input here, but we received one comment saying that, well, it's quite a lot of information for maybe for a very short webinar, but the important thing was to share today the different parts of the project, and give an overview. And then, of course, you can get in touch with us if you have for further information. And as José María mentioned, we will keep this Miro open. So after this webinar, we're going to share all the presentations, and we will keep the Miro open to collect your feedback in this way. It's really very important to get feedback from you, because we are in a moment on the project just halfway through, and your feedback can really inform the decisions that are going to be made and have an impact on them. So, well, there was a question about Work Package 4, modeling of emerging mobility solutions, about if there are publications on modeling framework. And yeah, well, Santana Krishnan already shared in the chat I think this, well, I let you answer this, Santana Krishna.
Yeah, currently we have submitted that to a conference and it's under review now. But in case you are interested, kindly write to us and then we can share the details.
Okay, so it's really work in progress right now. If you have more questions, please don't hesitate to write them. But as said, you will have still one more week. Also, if you prefer, you can write them in the chat as well, if it's more comfortable for you. But it's true that it's a lot of information in a very short time, and we will wait for one more week to receive your feedback. Okay. Okay, we're not seeing more questions coming through. So as mentioned before, the webinar will be published in YouTube, so you can rewatch it. We will share the presentations with all the attendees. The Miro board will still be open to collect your feedback, and you can also get in touch with us. In the first presentation, you have all our contacts, and don't hesitate to get in touch with us if you need further information or if you have any questions. Also, in the Momentum website, you can find all the information that has been published already. So I would like to thank a lot the speakers today, Sergio, Javier, Antonio, Santana Krishna, and Josep Maria for their presentations. Also, Niklas for the technical support and the work behind scenes, and also to all the attendees for your engagement as well, for answering our questions and giving feedback, and for being interested in the project and for being here today. So we'll keep you posted on the project advancements, and we see you soon. Thanks a lot.